All right, today we're going to talk about field properties of addition and multiplication, which I know are everybody's favorite thing, memorizing properties. What I would like you to do before you do this video is take a look at the property do now that comes right before this paper. There are some multiple choice questions, and if you haven't tried those multiple choice questions yet, I want you to go ahead and give those a try. It's going to remind you of the names of some of the properties, and hopefully that will make this lesson go a little bit easier for you. So if you haven't done that, do now. Stop it, stop the video, go back, give it a try, 2-3 minutes tops, and then come back to me. Okay, hopefully you're now familiar with the names of the properties. We've got commutative property, we've got associative property, we've got the identity property, we have the inverse properties. We are also going to be talking about some properties at the end of this video that are properties of equality, properties that you've probably never heard of. So in order to really get something out of this video, what I want you to do, we're going to do sections of 2 at a time. So what I want you to do, stop the video for a minute, read the first 2 explanations, and just think about what that says, and just think if you know what the property is. So hopefully you notice that these first 2 properties are talking about order. When you change the order in which you add or multiply, that is called the commutative property. So the first one, and you should fill this out, the first one is the commutative property, spelled with a T, not an N. We're not communing, we're commuting. So this is the commutative property of addition. And I'm just going to write a plus sign. And the next one is the commutative property of multiplication. So basically, what your numbers and variables are doing here is they are commuting. So commute means to go from one place to the next. So if I start at place A and I go to place B, when I'm done at place B, I'm going to start at place B and go back to place A. Or I could, and the distance there doesn't change. So a basic example was if I take 2 things like x and y, if I add x plus y together, that will give me the same result as y plus x. A harder example, I could be doing lots of different things. I could be doing something like I could have 2 and then in parentheses, I could have x plus 3. And then I could say, well, that's going to equal 2, and in parentheses, 3 plus x. So if you look at what I did from one side of the equal sign to the other, is I'm changing the order of addition. That's the commutative property. Now, the commutative property of multiplication, I'm just changing the way I multiply. So I could say x times y, and I could just write it xy, will give me the same result as yx. Now taking a look at the example above where I did the 2 times the x plus 3, I could write it like that as well. I could say 2 and in parentheses x plus 3, but to be the commutative property of multiplication, I would need to change the order of the multiplication. So I would say, well, that's the same as saying x plus 3 in parentheses times 2. So there what I did is I changed the order of multiplication. Now stop the video, read the next 2, and see if you can remember what that one's called. All right, those 2 are grouping, right? So the way you group things, that's the associative property. So both of these are the associative property. The first one is the associative property of addition, and the second one is the associative property of multiplication. I'm just writing associative of addition and associative of multiplication. When I draw the star, that's me saying that I'm talking about multiplication. Now, associative, the order doesn't change. What changes is who's being grouped together. So for addition, I could say x plus y plus z, and in the I could put x and y together. I could group the x and y together in parentheses, and then I would say x plus y plus z on the other side of the equal sign, but this time I'm putting the parentheses together with the y plus z. So if you look from one side of the equal sign, order doesn't change. What changes is who's inside the parentheses. The same thing would happen with multiplication. I could do x times y times z, and this time let's group the y and the z together. That will result in x times y in parentheses times z. So what's changing is who is being grouped together. The result doesn't change because it's all multiplication. It doesn't matter who you're grouping together. But if you're looking from one side of the equal sign to the next, the order doesn't change. So a helpful thing that I try to remember between commutative and associative is commutative is changing order, and commutative starts with CO, which is change order. And then associative is grouping. And if I'm associating with you, I'm like hanging out with you. We're kind of grouped together, right? And so associative is grouping numbers together. All right? Take a moment again, pause the video, read the next two, and see if you can think about what that property would be. Both of these are talking about an identity. So the sum of a number and zero, you will always get the number you started with. So the identity of a number doesn't change if you add zero to it. That would be the additive identity property. And the next one has an identity of 1, the product of a number and 1. So if you multiply a number by 1, you will always get the number that you started with. That's called the multiplicative identity. So the identity of a number or a set of numbers doesn't change when you multiply by 1, and it doesn't change when you add 0. So this one is multiplicative identity. So in a basic example of additive identity is I could take a number, let's call it x, and I could add 0. Well, I'm just adding 0, so my result's going to be x. I could make it look crazy and fancy, like I could say x squared y plus 0. That's still going to result in x squared y. The same is true if you multiply by 1. I could say x times 1, and that's going to give me x. I also don't have to put the x or the 1 at the end. I could say something like 1x squared y. Well, 1x squared y is the same as x squared y because 1 times anything will give you that same thing back. Go ahead and stop the video now and read the next two. So these next two are talking about opposites and reciprocals. So this first one, the sum of a number and its opposite is 0. This one right here is the additive inverse. So this one's saying if you add two opposites together, so opposites are positive and negative numbers. So if I say 3 plus negative 3, well, those are going to cancel each other out. That's true for variables as well. I could say x plus negative x, because those two numbers are opposites of each other, that's going to result in 0. That's true for, I could use lots of variables. I could say negative ab squared plus ab squared, because both of those are opposites. They're going to cancel each other out, and the result will be 0. That's called the additive inverse property. The next one is the product of a number, and its reciprocal is 1. So product means I'm multiplying. Reciprocal is when you flip a number. So this is called the multiplicative inverse. And the reciprocal is when you flip it. So I could say A over B times the reciprocal of A over B is B over A. Now, if you think about what we learned with multiplication, these A's here, they're going to cancel out to give us 1 because they represent the same number. And these B's are going to cancel out to give us 1 because they represent the same number. The result will always be 1. So if I have just a basic, I could have a crazy looking fraction like x squared y over 2. Well, if I multiply by 2 over x squared y, everything will cancel out and leave us with 1. All right, now the last one is pretty simple. The product of a number ends 0 is always 0. This is called the multiplication property of 0. And that one you've known forever, but maybe you didn't know it had a name. So whenever you multiply by 0, the result will always be 0. So it doesn't matter what I have. Let's say I could have x to the 10th, y to the 50th, divided by z to the 8th, plus 2. And let's say I put the whole thing in parentheses, and I say times 0. Well, the result is going to be 0. It doesn't matter what's inside those parentheses, because if I multiply it by 0, anything times 0 is 0. So those are the basic properties of addition and multiplication. Now, notice that I said addition and multiplication. These are rules that only work for addition and multiplication. If I throw in subtraction or division, these rules don't work, right? Order matters when you're subtracting or dividing, right? And also dividing by 1 and dividing by 0 are all things that mean something different. So keep that in mind. These rules only work for addition and multiplication. So now let's jump to some new algebra properties. So notice the properties of equalities I've left completely blank because I am guessing that you know nothing about these. So I'll just tell you the names of them right away. The first one is called the reflexive property. Reflexive. The second one is called the symmetric property. And the last one is called the transitive property. All right, so now the reflexive property. The reflexive property is one of the most basic properties that you will ever be taught. You have been told since day one when you were learning about equal signs. If two symbols or numbers look the same, they are equal. That is all the reflexive property says. If two things look the same, they are equal. That definition is simply A equals A. So an example would be if I say 3x squared over 2 plus 1. To be the reflexive property, I would have to say that that also equals 3x squared over 2 plus 1. So the reflexive property is when both sides of the equal sign are exactly the same. Nothing changes. No order changes, parentheses don't change. Both sides are exactly the same. You know they're equal. That's called the reflexive property. The next one is called the symmetric property. The symmetric property simply says if A equals B, then B equals A. So what this is saying is if I have an equation and I just switch what's on one side of the equation, they're still the same. So we do this all the time as well. You're solving an equation and let's say you get x equals 5. Well, x equals 5 is the same as 5 equals x. So this is an equality property, so you have two equations, right? If x equals 5, then 5 equals x. Often, this property will have if this happens, then this happens, right? And it's true with real numbers as well, right? Like if I say 2 plus 4 equals 6, then you know 6 is still equal to 2 plus 4. So the symmetric property is just saying it doesn't matter what side of the equal sign a number is on. If they're equal, they're equal. Now, the transitive property, I love the transitive property. The transitive property says if A equals B and B equals C, then what must be true? A equals C. So the example I'm going to give you is suppose I say if x equals 5, the word if there, and 5 equals 3 plus 2, then x must equal 3 plus 2. So basically, if one thing equals something, and that something equals something else, then the first thing you started with must also equal the last thing. And that's called the transitive property. Now, the way that I remember the transitive property is it's kind of like, it has the word transit in it. And I think of transit stations or train stations, which just takes me into trains are really long. And this property is saying if this happens and this happens, then this happens. And then I remember the symmetric property because I think about shapes that are symmetric. So side note over here by the symmetric property, if I draw a diamond, that's perfectly symmetrical. Well, that means if I fold it or draw a line down the center, they fold onto each other, they will match. This is similar. If you think about A being equal to B and B being equal to A, if you are drawing a line down here like it's symmetric and you fold that piece of paper, the B will match up with the B and the A will match up with the A. Not perfectly, but like they're in the same spot. So that's how I remember the symmetric property. And the reflexive property is like you're looking in the mirror. You see each other, right? A equals A. Two things are the same, right? So that's the way that I remember that. Now, in order to get good at properties, you have to see lots of examples and really look at what's happening in each of them, okay? So I have some examples. What I want you to do with these is I've given you a property and I've given you 4 examples for each property. Some of them are true, some of them are false. I want you to think about that property. I want you to go back and look at the definition, look at the example, and I want you to see if you can find the false ones. Okay, so it could be a true statement, but is it true to that property? Okay, so for example, I'll do the first one with you. The multiplication property of 0. If you go back and look at the definition and look at the example, the multiplication property of 0 is saying If you multiply something by 0, the result is 0. So if you look at all 4 of these properties, they all do equal 0, but which ones do not multiply by 0? So the first one is multiplying by 0, so that one's good. So I'm not going to cross that one off. But the next one, negative 2x plus 2x, negative 2x squared plus 2x squared, that's actually the additive inverse property because we're not multiplying by 0. So we're going to cross that one off. Now C, I'm saying 0 equals 2xy times 0. That's the multiplication property of 0, even though the 0 is at the beginning and not at the end. It's still multiplying by 0, the result is 0. So that one's good. The next one is subtraction, right? This one, not the multiplication property of 0, all right? So I want you to try the rest of these on your own. In fact, do a row at a time and then tune back into the video to see if they're right. So stop the video, try the commutative property one and the multiplicative inverse one. Then come back to me and see if you've done them correctly. All right, so for the commutative property, the only one there that you can cross off is letter A, because that letter A is actually the associative property, because order doesn't change, just whose grouping does. And the only one you can cross off on the next one, multiplicative inverse, is B, because that one you're actually multiplying by 1. That's not even a true statement. Now, you may have forgotten in the first one, letter A, remember 2x squared can be written as 2x squared over 1. And then the reciprocal of that is 1 over 2x squared. So everything cancels out. The result is 1. And then the other thing for letter C, don't let the negative mess you up. Remember, negative signs on fractions, that negative sign can be written on the front or it can be popped up to the top. It also technically can go to the bottom. It's just not where we put it. So that negative times the negative is going to end up giving us a positive. So everything there will cancel out to give you 1. So go ahead and stop the video. I want you to try the next 6 on your own and then come back and check to see if you've done them correctly. Seriously, you want to stop the video, just try it, and then come back and check your answers. All right, so here are the answers to the next 6. I want to point out the one that you might have crossed off with additive inverse. I put a star by it. This technically is considered additive inverse because remember when you're subtracting two numbers, that is the same as adding the opposite. So because this can be written as plus a negative 2xy, we're still going to call that additive inverse. So that was the tricky one. All right. Now, what I would say to do is if there's any of them that you got wrong or you have a question about, make sure you put a star or a question mark it in some way so that you know that those are the ones that you want to ask me about. Remember, you can also send me an email with your question. So that right there are all of the field properties. These are things that you might need to make flashcards for or study in some way, shape, or form. Basically, you just have to be able to see what's happening in the problem and identify it with a property.